Welcome to Unstuck. Today, insertion sort, the way you sort a hand of cards without thinking about it. We'll build it one line at a time, watch it sort live, and see why, unlike bubble sort, real libraries actually use it. Beginner friendly, slow, and clear. Picture holding playing cards. You pick up each new card and slide it left until it sits in the right spot among the cards you've already sorted. That's insertion sort. Grow a sorted section on the left, one element at a time. It's simple, it's stable, and it's genuinely useful. A like helps if this is your kind of thing. Let's build it line by line. The idea, treat the left part of the array as already sorted. Take the next element, call it the key. Shift every sorted item bigger than the key one slot to the right, opening a gap, then drop the key into that gap. Repeat until the whole array is sorted. Here's the code. The outer loop starts at index 1, first line, grab the key, the element we're about to insert into the sorted left part. We save it in its own variable because we're about to overwrite its slot. Next, J starts at the key's position. A J is the finger we'll walk leftward looking for where the key belongs. The inner while loop while we haven't hit the start, and the item just to our left is bigger than the key. That condition is the whole logic. We only move left as long as there are bigger elements in our way. Inside the loop, copy that bigger left neighbor one slot to the right and step J left. We're not swapping, no? We're sliding the big elements over to make room, which is faster. When the loop stops, J is exactly where the key belongs. Drop it in. That's the entire algorithm. Grab the key, shift bigger ones right, place the key. 5 lines. Watch it run on 5, 2, 4, 6, 1, or 3. Insert 2. It slides in front of 5. Insert 4, insert 6, insert 1. It walks all the way to the front. Insert 3 when it's sorted. See the sorted part on the left, growing by 1 each line. 3 is the hard one. Inserting the 1, its key is 1. 6 is bigger, shift. 5 bigger, shift. 4, shift. 2, shift. We've walked all the way to the front. J is 0, so we place the 1 at the start. Every bigger element, slid right to let it through. Now the numbers on 20,000 items. Reverse sorted, the worst case, 109 milliseconds. Already sorted, the best case, 12 microseconds. And nearly sorted, 18 microseconds. Almost as fast as sorted. This is the key difference from bubble sort. Insertion sort is ordering on nearly sorted data because the inner loop barely runs. Real-world data is often almost sorted, so production sorts like team sort and intro sort switch to insertion sort for small or nearly sorted slices. It's not just a toy. The scorecard, n squared worse than average, but order n on nearly sorted input, constant extra space, and stable equal elements keep their order. That best case behavior is exactly why it earns its place inside the big library sorts. Common mistakes. Starting the outer loop at 0 instead of 1, the first element is already a sorted list of 1. Forgetting the J greater than 0 guard, which walks off the front and panics in Rust. And swapping instead of shifting, which does double the writes. Recap, grow a sorted section on the left, inserting 1 key at a time by shifting bigger items right. N squared in the worst case, but order n when data is nearly sorted, which is why, unlike bubble sort, this one is actually used in real libraries. Quick one, but if these help you, the wallet's on screen and there's a coffee link in the description. Every tip funds the next one. The full Rust code is in the description. If this helped, hit like and subscribe. A new coding challenge every day. See you in the next one.